Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from November 2022, paper 2, variant 1. In this lesson, as always, we will discuss these questions in detail so you can improve your conceptual understanding of this topic and also you can have better understanding of these questions. Let's study together. Let's improve together. In today's lesson, we are talking about November 2022, paper 2, variant 1. Total time for this exam is 1 hour and 15 minutes and total mark for this paper is 60. If you want to get A star in A-level physics, you need to get in paper 1 about 35 out of 40 marks. And in paper 2, you need to get about 50 out of 60. And in paper 3, you need to get about 32 out of 40 marks. And in paper 4, you need to get 80 out of 100. And in paper 5, you need about 25 out of 30 marks. If you can get these marks in these papers, it means 100% you will get A star. On second page of exam paper, data is given to you, means values of some constants are given to you. If you need value of any constant for some calculations in your exam, you can come to the second page of exam paper and you can find values of constants. And also you need to understand at AS level, you have to use G is equal to 9.81 meters per second per second. You cannot use G is equal to 10 meters per second per second. You will lose marks if you use G is equal to 10 meters per second per second. So at AS level, you have to use G is equal to 9.81. You have to be very clear about this point. On second page of your exam paper, you can also find some important formulae, but these are not all the formulae you need for AS physics. So it's better if you can remember all the formulae, and also it's very important if you understand how to derive formulae, because it's very important to understand how to derive formula. Because when you derive a formula, you understand the basic physics behind that. So always try to derive formula. But for exam, you need to remember all the formulae for AS physics, but some important formulae you can find on this page. If you have forgotten any formula, you can come to this page and you can double check, so you will not make mistakes in your exam. For question number 1, part A, we need to draw a line between each term on the left and a correct example on the right. And this question is simply about System International, means simply about SI. In System International, we have base units and quantities, means base quantities and units. Also, we have derived quantities and units, derived. So we can also write on here, we have base quantities and also we have base units. Then also we have derived quantities and also the units, derived quantities and units. But we need to be very clear about this one. We have only 7 base quantities and base units, but we have much more than 7 derived quantities and the units. So it's very important. We have greater than 7 derived quantities and unit, mean much more than 7. So if this point is clear to you, now simply we can answer this question. First is asking you about base quantity. Base quantity. The base quantity is electric current. So we can simply say the base quantity is electric current, because this is the base quantity. In the 7 base quantities, electric current is one of them. So this is base quantity. Next one is asking us about base unit. kg is a base unit. So this one is base unit. Derived quantity. Force is a derived quantity. Derived unit. Coulomb is a derived unit, because coulomb we can derive from ampere. So this is derived unit. Coulomb is derived unit. So these things you need to understand. So SI system consists of 7 SI base quantities and 7 SI base units. And there are much more than 7 derived quantities and the units. I hope this point is clear to you. For the second part, it is given to us a set of experimental measurements is described as precise and not accurate. We need to state what is meant by precise and what is meant by not accurate. First of all, let's try to understand what is meaning of precision. Precise means that readings are close to each other. So in a simple language, we can simply say precise means that readings are close to each other. Readings are close to each other. So this is meaning of precise. Readings are close to each other. Or you can also say, in this case, readings have small range. If the range of the readings is small, it means readings are precise. We can also understand this one with one simple example. Imagine that we have readings 15.5 centimeters. We have 15.2 centimeters. We have 15.4 centimeters, and we have 15.0 centimeters, or we have 15.3 centimeters. So in this case, these readings are very close to each other. Imagine that the actual value is 17. So we can imagine that actual value is 17 centimeters. But this is the data. These are the measurements we have taken with the help of instrument. Now, if you look at these given values, these values are close to each other, but they are not close to the actual value. So this data, we will say this data is precise, but this data is not accurate. So this one is not accurate. So this is not accurate. Later we will discuss accuracy in detail. So this data is precise because readings are close to each other and the range is small. So this data is precise. So let me show you the answer, how you can write on the answer. So you can simply say the measurements have a small range. So this is how you can define precision. Or you can say measurements are precise. Now let's try to understand what is meant by not accurate. When data is accurate if the mean value is close to actual value. Then we can say data is accurate. Mean value is close to actual value. So we can say data is accurate. So this is how you can define accurate. Your data is accurate if the mean value of your data is close to the actual value. But in this case, if you take the mean value that is not close to 17 centimeters, so it means this data is not accurate. So this is the point you need to understand. So data can be precise, but still it cannot be accurate. For the second part, this is how you can write on your answer. Simply you can say average of the measurements not close to the true value, or you can say mean of the measurements is not close to the actual value. I hope this point is clear to you. What is meant by precision and what is meant by accuracy. So when we talk about accuracy, we calculate mean value of the data and we compare that one with true value. And when we talk about the precision, so if the measurements are close to each other, they have the small range, we can say data is precise. You can also understand like this. Imagine that these fingers, these are the measurements. If these measurements are close to each other like this, so it means this data is precise. If these measurements are away from each other, so it means this data is not precise. For part C, formula for the force is given to us and percentage uncertainties for force, for mass and radius are given to us. And we need to calculate the percentage uncertainty in V for part 1. So very straightforward question. So the best way to answer this problem is, first of all, you can rearrange this equation. So if we rearrange this one, we can simply write down V square. This one will be equal to FR divided by M. So we have to make V the subject because we need to calculate the percentage uncertainty in V. So now simply we can write down V in this case will be equal to FR divided by M, and the power of this one is 1 by 2. We need to calculate the percentage uncertainty in V. So the percentage uncertainty in V, this one will be equal to 1 by 2 times percentage uncertainty in F plus percentage uncertainty in R plus percentage uncertainty in F. So this is the point we need to understand, because in this case these quantities are multiplied and divided, so we need to add percentage uncertainty, and this also has a power, so we have to multiply by power. Power is 1 by 2, so we have to multiply by 1 by 2. Now simply we need to plug in values. Percentage uncertainty in F is given to us, that is equal to 3%, so we can say this is 3%. And percentage uncertainty in R is given, that is 5%. So we can write down this is 5%, and percentage uncertainty in mass is given, that is 4%. Now simply if we add all of them together, we will get this is 1 by 2, and here we will get this is 12%. Now we divide by 2, so we will get 6%. So this is our final answer. So this is the percentage uncertainty in V, and this is how you need to approach. For the second part, it is given to us the value of V is 15.0 meters per second, and we need to calculate the absolute uncertainty in V. But we have already calculated percentage uncertainty in V, and percentage uncertainty in V, this is equal to 6%. So we can convert this one into fractional uncertainty, so we can say delta V by V, this one will be equal to 6 divided by 100, because this is 6%. Now question is asking us to calculate delta V. So delta V simply will be equal to 6 divided by 100 multiplied by V, and V in this case is equal to 15.0. So if we solve this one, our final answer will be equal to 0.9 meters per second if we use only one SF. Up to one SF, our answer will be 0.9. And absolute uncertainty at AS level, you have to write down up to one SF only. So our final answer for this question is 0.9. One SF only, very important. So at AS level, you have to use only one SF for absolute uncertainty. For the second question, it is given to us a steel ball is projected horizontally from the top of a table as shown in figure 2.1, and its horizontal velocity is given to us, and also horizontal displacement is given. For this question, we can also assume A resistance is negligible. If A resistance is negligible, it simply means that there is no force along horizontal, so the acceleration along horizontal will be equal to 0. So simply we can say in this case AX, this is equal to 0. So simply we can say horizontal displacement X, this is equal to UX times time plus 1/2 A t square. But in this case AX is equal to 0, so it simply means that horizontal displacement is simply equal to X times UXT. We need to calculate T for this question. So T is equal to X horizontal displacement divided by UX, means the initial horizontal velocity. Value of X is given to us, but X is given in centimeters, so we have to convert this one into meters. So we have to divide this one by 100 divided by velocity is given in meters per second, so simply you can use 4.9 meters per second. And if we solve this one, our final answer in this case will be equal to 0.37 seconds. So this one is the final answer. Our final answer has 2 SF because the raw data, it has 2 SF. For the second part, we need to calculate the vertical component of the velocity of the ball as it hits the ground. If you look at this point, the horizontal component of the velocity, it will be equal to the initial horizontal component of the velocity, and that is equal to 4.9 meters per second. Then question is asking us to calculate vertical component of the velocity when the ball hits the ground. Mean this component of the velocity we need to find out. We need to find out vertical component of the velocity, so we need to consider only vertical motion. So we can say V sub V, vertical motion. So we need to look at vertical motion only. So the best way to answer this problem, you can simply write down vertical motion. If you look at vertical motion, initial vertical velocity is 0. So we can say UV, U sub V is equal to 0. But in this case, we have already calculated time taken from this point to the ground, or you can say from this point to this point, or you can say from this point to this point. Horizontal or vertical time taken is the same. So time taken is equal to 0.37 seconds. Now question is asking us to calculate value of V, but in this case acceleration A, this is equal to G, and value of G is equal to 9.81 meters per second. We need to calculate value of v. So v we need to calculate, means the final vertical velocity we need to calculate. So simply we can say v sub v in this case will be equal to u sub v plus 80, and in this case we will take downwards as positive. So we will take downwards as positive. So if you take down as positive, it means acceleration is positive. Now simply you need to plug in values. In this case u sub v is equal to 0 plus we have 9.81 times we have 0.37. So the final answer in this case is equal to 3.6 up to 2 SF, because the raw data, this has 2 SF, means the least number of SF in the raw data. This is 2 SF, so our final answer also should have 2 SF, or you can use one more. So this is the final answer. For the third part, we need to determine the magnitude and angle to the horizontal of the velocity of the ball as it hits the ground. But we have already calculated vertical component of the velocity, and we also have the horizontal component of the velocity. So simply we can rewrite again. So we have horizontal component of velocity that is equal to 4.9 meters per second, and we have calculated vertical component of velocity. That one was equal to 3.6 meters per second. Now we need to calculate in this case final velocity. So you can in this case simply draw this arrow, and this is representing direction of final velocity. And this velocity has two components. We can take this component, we can place this one here. So this one is the triangle. Simply you can imagine this is the triangle. So we have horizontal component, we have vertical component, and the value of this one is 3.6 meters per second. And question is asking us to calculate this angle, and also the value of v. We can simply say this is v. So if we need to find v, so v in this case simply will be equal to 3.6 square plus, because this is right angle triangle, plus 4.9 square. And if we solve this one, we can find out value of velocity, and that will be equal to 6.1 meters per second. So the magnitude of the velocity is 6.1 meters per second up to 2 SF. We need to find out this angle. So the angle simply we can say in this case tangent of theta. So we can say this angle is theta. This will be equal to vertical component divided by horizontal component. From here we can calculate value of angle. So this is theta. So we can take tan inverse of 3.6 divided by 4.9, and final answer will be equal to 36 degrees up to 27. So this is the value of angle with horizontal. For part B, it is given to us the ball is a uniform sphere of steel of diameter 0.016 meters and the mass of the ball is given. We need to calculate density of the steel. So quite straightforward question. We need to calculate density, and we have the mass. So if we can calculate volume, so we can find the density. So in this case, mass is given, that is in SI base unit. So we can simply say 0.017 kgs divided by volume. And volume of the sphere is 4 by 3 pi r cube. And simply we need to plug in values now. So we can say this is 4 by 3 pi r cube, but the diameter is given to us, and this is also in SI base units. So simply we need to divide diameter by 2. 0.016 divided by 2, and we need to take cube of this one. Now if we solve this, our final answer in this case will be equal to 7,900 kgs per cubic meter up to 2 SF. So our answer is up to 2 SF, because the raw data we have, this has 2 SF, this one has 2 SF, this also has 2 SF. So our final answer also we need to use least number of SF in the given data. So our final answer is 7,900 kgs per cubic meter. For the second part, it is given to us all of the elastic tension energy in the spring is converted into kinetic energy of the ball. The speed of the ball as it leaves the spring is 4.9 meters per second, and we need to show that maximum elastic tension energy of the spring is equal to 0.20 joules. First of all, let's try to understand this one with the help of this figure. When the spring is fully compressed, at this point, its initial elastic tension energy, this has maximum value. So it has maximum value. And at this position, ball is not moving, so the kinetic energy of the ball, this one is equal to 0. And when this spring is unstretched means the compression in the spring, this is equal to 0. At that point, EPE will be equal to 0. So we can simply say EPE final, this is equal to 0. And kinetic energy of the ball at this point, this is maximum. So this is final kinetic energy and this one is maximum. And this question is simply about conservation of mechanical energy. So we can say in this case EPE, the change in EPE, this is equal to change in kinetic energy. And total change in energy in this case is equal to 0. And change in EPE, final EPE is equal to 0. So we can simply say the change in EPE is equal to EPE maximum. So we can say this is EPE maximum. So EPE maximum means the initial value of EPE. This is equal to final value of kinetic energy. And final value of kinetic energy is 1/2 mv squared. And these two quantities are same. So simply we can plug in values. Mass is equal to 0.017. This is mass of the ball. And speed of the ball is given to us. That is 4.9. We have to take square of this value. If we solve, our final answer will be equal to 0.20 joules up to 2s. And this is what we need to show, that maximum elastic tension energy is equal to this value. So this question has 2 marks. You will get the first mark if you have written this formula, and the second mark if you have got the right answer. For third part, we need to use figure 2.4 to determine the spring constant K of the spring. But we have force on y-axis and we have compression, means we have x on x-axis. We need to find out value of K. So simply K in this case will be equal to force divided by extension. So we can take any value of force. In this case, I'll be choosing this point. At this point, we have value of force that is equal to 6.4 newtons, and we have value of extension that is equal to 10 centimeters. So we need to multiply this one with 10 to minus 2 because we have to convert this one into SI base units. And now simply if we solve this one, our final answer will be equal to 64 newtons per meter. So this one is the final answer. For part 4, we need to use our answer from B3 and the value of energy given in B2 to determine the compression x0 of the spring. In part B2, it was given to us that EPE, elastic tension energy, is equal to 0.20 joules. In part B3, we have calculated value of K that was equal to 64 newtons per meter. Now we need to calculate value of compression. So simply you can say in this case EPE is equal to 1/2 kx squared. And we need to find value of x. So if we rearrange this one, we can write down in this case x squared. This one will be equal to 2e divided by k. We need to find out value of x0. So we have to take square root on both sides. So we can say 2e divided by k. And now we can plug in values. So we have value of e that is equal to 0.20, and this is divided by K, that is equal to 64. And we need to take square root, means the power of this one is 1/2. If we solve this one, value of x will be equal to 0.079 meters. So this is our final answer up to SF. For part C, it is given to us the steel ball is replaced by a polystyrene ball of the same diameter but of much lower mass. The spring is given compression x0 and is then released. Air resistance on this ball is not negligible after it leaves the spring. We need to explain why this ball leaves the spring with a greater speed than that of the steel ball. So first thing we need to understand, in this case, compression in the spring is the same. So we can say elastic potential energy is the same. So EPE is the same for these two balls. And EPE in this case will be equal to 1/2 mv squared. Mean the change in EPE, this is equal to change in KE. Simply we can say the loss in EPE, this is equal to gain in KE. And from here we can find out the speed. So V will be equal to 2 times EPE divided by m and root of this one. From here, you can simply see that if the mass is lower, it means speed will be greater. So the polystyrene ball will have greater speed because it has lower mass. So these two balls, they have the same EPE, and the second ball, it has lower mass. So the speed of second ball will be greater. So let me show you the answer. This is how you can write down the answer. In your answer, you can mention these points. They have the same elastic potential energy, and polystyrene ball, it has lower mass, so the speed of this ball is greater. For the second part, we need to explain why this ball takes a longer time to reach the ground than the steel ball. But in this case, it is given to us the steel ball has a greater mass. So we can say this one is steel ball. Let's say the mass of the steel ball is capital M, and the mass of polystyrene ball, let's say, is small m. So the initial force acting on steel ball, this is equal to its weight. So this is capital mg, and the initial force acting on this one is small mg, and this force is lower than the force on the steel ball. Now after a short period of time, if we draw the free body diagram, let's say the air resistance on these two balls is the same. So we will see air resistance in this case equal to this. Just imagine that. So this is the mg, and in this case the resultant force will be this big. So this one will be the resultant force. But if you draw free body diagram for this one after a short period of time, so we will say in this case this is the weight of the second ball, and air resistance, if we draw the equal length of arrow, so this one is air resistance, and in this case F net is almost equal to 0. So F net is almost equal to 0, but in this case we have F net because the weight is greater than air resistance. So this ball is still accelerating downward, but this one has reached terminal velocity. So simply net force on the second ball is smaller, so this will take longer time to reach the ground, and net force on steel ball is greater, so it will take shorter time to reach the ground. Or simply we can say the effect of air resistance on this one is more significant as compared with effect of air resistance on steel ball. So if we have understanding of these points, and then simply we can write down an over answer. In answer, if you only mention about resultant force, you will get 1 mark because this question has only 1 mark. So we can say for the polystyrene ball, there is less resultant force, so it takes longer time to reach the ground. You can see here it's a beautiful way I have explained to you here. So let's try to understand this one in a bit proper way. If you want to draw a proper free body diagram. So let's say for the steel ball, after a certain period of time, we have air resistance acting on this. Let's say this is representing air resistance, and the force acting downwards, that one is the weight of this. So this is the weight of the steel ball. And also we can draw polystyrene ball here. So this is polystyrene ball, and air resistance on this one is also the same. So after a certain period of time, because they have the same size, the air resistance is the same. So we can draw a bit longer, 0.7. This is 0.7 centimeters. Now, if we draw in this case, the weight of this one is lower than the weight of the steel ball. So in this case, you see these two forces are almost balanced. So it means it has already reached terminal velocity. So this one will take longer time because the resultant force on polystyrene ball is smaller than resultant force on the steel ball. So steel ball is still accelerating, but this one has reached terminal velocity. So this one will take longer time. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics and waves from November 2022, paper 2, variant 1. In this lesson, as always, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together. Let's improve together. For our third question, part A1, we need to define power. And power is simply rate of doing work. If you do work faster, means you do the same amount of work in a shorter time. It means your power is higher. If you do the same amount of work in longer time, it means your power is lower. So simply we can say power is equal to work done per unit time. Work done per unit time. So in this case, if we fix time, if we keep time constant and we increase the amount of work done, it means the power is greater, and vice versa is also true. So for the answer of this question, simply we can say work done per unit time. So if you write on this one, you will get 1 mark. Now let's go to the second part. For the second part, it is given to us that mechanical power can be calculated using the formula F is equal to PV. Use the concept of work and definition of power to show how this formula is derived. And this question has 2 marks. So first thing it is given to us, we have to use the concept of work. So we will write down in this case, work done is equal to force time displacement in direction of force. So this is how you can write down work done. This hint is given to you. So you have to use the concept of work. So we have written W is equal to Ft. Now it is also given to us, we have to use the definition of power. So we can write on power here. Power is equal to work done per unit time, or you can say work done over time taken. And so we can replace W with Fd. So this is Ft divided by T. And in this case, D over T, this is the speed. So D is the displacement in direction of force. So this is D over T. So D over T, simply we can say this is equal to speed. So power is equal to force times velocity, or you can say force times speed in this case, force times speed. So this is what you need to do for the answer of this question. So simply you need to say power is equal to force times speed. For part B, it is given to us the engine of a lorry provides 130 kilowatts of power to the lorry's wheels when it is traveling at a constant speed of 25 meters per second along a straight horizontal road. We need to show that the resistive force opposing the forward motion of the lorry is 5,200 newtons. This question is quite straightforward one. First of all, simply we can imagine this is straight horizontal road, and on the top of this road we have a lorry. So this one is the lorry, and there is an engine forced by the lorry that is pushing this one forward. We can say this force is capital F. We can also imagine in this case resistive forces acting on this lorry, we can say are equal to F. So these are the resistive forces, sum of all the forces due to friction and a resistance as well. So we are simply saying these are resistive forces. As this lorry is moving at a constant speed, it means this F has to be equal to this F. So the thrust force in this case is equal to resistive force. So simply we can say power will be equal to F times V, or we can say this is equal to resistive forces times V. We need to calculate in this case resistive force. Fr we need to calculate. So this is simply equal to power divided by the speed of the lorry. And power is given to us, that is equal to 130 kilowatts. So we have to multiply this one with 1000, and we need to divide by its speed. Speed is 25 meters per second. Now if we solve this one, our final answer will be 5200 newtons up to 2SF. So this is up to 2SF. Because given data, we have 2SF here, we also have 2SF here. So we have to use the least number of SF in our final answer. So this one is our final answer. For part C, it is given to us the lorry in B travels up a straight section of road that is inclined at an angle theta to the horizontal, as shown in figure 3.1. Now the lorry is inclined, mean is going up. The road is not flat, or simply you can say the road is not horizontal. So there is an angle theta. The lorry has mass m and acceleration of free fall is g. For part C1, we need to derive an expression in terms of m, g, and theta for the component of the weight of the lorry that acts parallel to the surface of the road. Component of the weight. So first of all, we can draw our vector for weight, mg. This is weight of the lorry that is acting vertically downwards. So simply we can say this is mg. As this lorry is not moving up and down, so it means there is a force that is acting up up here. So there is a normal reaction force. As this lorry is not moving up and down, so it means there is a component of the weight that is acting opposite to that contact force. So here is a component of weight here, and there is also component of the weight that is acting opposite to direction of motion of this lorry. As in this case, this angle is theta, so this angle is also theta. We can say this is normal reaction force, contact force, and this component with angle will be mg cosine of theta, and component of the weight opposite to the angle, that one has to be mg sine of theta. And this component of the weight means this component of the weight, this is parallel to the road, and question is asking us to write down component of the weight that is parallel to the road. So simply you have to write on mg sine of theta in this case. So if you write on this one, you will get 1 mark. For the second part, it is given to us the total resistive force remains unchanged at 5,200 newtons, and the engine now provides greater power to maintain the speed of 25 meters per second. The total mass of the lorry is 36,000 kgs and the angle is 1.4 degrees. We need to determine the power in kilowatts provided by the engine. So in this question, it is given to you the power is greater now. So if the power is greater, it means the thrust provided by the engine that is greater than before. So if the thrust is greater, so the resistive forces also have to be greater. I mean the sum of resistive forces has to be greater than before because the power is greater and speed is the same. So this is one thing you can understand from this question. Now if you look at forces acting on this lorry, as we have already discussed that mg, this is acting vertically downwards, and there is a resistive force that is opposing the motion of the lorry, and that resistive force is mg sine theta. So we can write down mg sine theta. This component of the weight is opposing the motion of the lorry, and this component we have discussed, this is mg cosine theta, and this component is acting opposite to the normal reaction force, And so in this case, motion of the trolley is only opposed by mg sine theta. So if we write down the forces opposing the motion of the trolley, so there are two forces. One force we have already discussed, that was Fr, and that was equal to 5,200 newtons. Then there is an additional force now, that is mg sine of theta. So this is the total force that is opposing the motion of the trolley. So in this case, we can also draw the thrust force provided by the engine. Let's say that is equal to capital F. So now in this case, if we write down the power, the new power provided by the engine, that one has to be equal to capital F times V. But in this case, capital F, that is equal to 5,200 plus mg sine of theta, and value of angle is given to us in this case, and the speed we have, that is 25 meters per second, and we need to find out value of p in this case. Now we just need to plug in values of mass g and theta to calculate value of p. So simply we can say in this case we have 5,200 plus m is the mass of the lorry, that is 36,000 kgs, multiplied by g, that is equal to 9.81, multiplied by sine of angle, and angle in this case is 1.4 degrees. Then this all we have to multiply by 25. So if we multiply, our final answer in this case will be equal to 350 kilowatts up to 2SF. Our answer has to be in kilowatts. So this is our final answer, and this is how you can answer this problem. Pretty straightforward one if you read question carefully and try to visualize, not just look at the formula and try to plug in values. You have to visualize. You need to understand the situation, what is given to you and what is happening, and then you can answer this question easily, and also you can improve your understanding of physics. So try to visualize the given problem and then start working on that problem. For question number 4, part A, it is given to us polarization is a phenomenon associated with light waves but not with sound waves. For part A1, we need to state the meaning of polarization. In order to understand polarization, simply we can imagine that unpolarized light. So simply you can imagine this one is unpolarized light. In this case, electric field can oscillate in all possible directions. So these are possible directions. If we pass this unpolarized light through a vertical polarizer, we will get vertically polarized light. So this one is vertically polarized light, and this is polarized. And in this case, wave is traveling to the right. So this is direction of travel of the wave. So in this case, simply we can see the angle between wave and this polarized light angle is 90 degrees. And also this electric field is oscillating in only one direction. Simply you can say it is only in one plane. So it's moving up and down. So oscillations are up and down. So we can say this is in one direction, or simply we can say this is in vertical plane, only in one plane. And direction of wave is at angle of 90 degree to oscillations of electric field. So this process we call is polarization. Means the light waves we can polarize in this way. And this process we call is polarization. That this phenomenon is not demonstrated by sound waves, because sound wave they just move in one direction, and oscillations of the particles they also in the same direction. So the sound waves cannot be polarized, but light waves can be polarized. So let me show you the answer, how you can write on your answer. In your answer you can mention these points. One thing you can say, oscillations are in single direction, which is perpendicular to direction of propagation of the wave. So in this case, simply you can imagine that oscillations are in this direction, up and down. Simply you can imagine oscillations are in these directions and wave is moving to that. So this is polarization. But if we go to the second part, question is asking you state why light waves can be plane polarized, but sound waves cannot. So the reason is that if we imagine a sound wave that is traveling to the right, so in this case, the motion of the particles, mean oscillations of the particles, they are in direction of wave. They are moving parallel. So oscillations are parallel. So these are oscillations. These are parallel. So that's the reason sound waves cannot be polarized, because they are just in one plane. So they cannot be polarized. But light waves can be polarized. For the second part, this is how you can write down your answer. Simply you can say light waves are transverse waves. That's the reason they can be polarized. They can oscillate in any possible direction, and oscillations have to be perpendicular to direction of propagation of the wave. So they can be polarized. But sound waves, they are longitudinal waves. They cannot be polarized, because direction of propagation of wave and oscillations of the particles, they are in the same plane. For part B, it is given to us unpolarized light passes through filter A, and filter A has vertical transmission axis. It simply means that after passing filter A, light will be vertically polarized. So this is vertically polarized light. And the intensity of this light is given to us, that is equal to I naught. And when this vertically polarized light, it will pass through the second filter, filter B, and filter B has horizontal transmission axis. It means the intensity of the light after passing filter B will be equal to 0, because angle between these two filters is 90 degrees. So cosine of 90 will be equal to 0. You can also use Malus's law. IT, this is equal to intensity of incident light times cosine square of theta. And theta is the angle between these two transmission axes. And in this case, angle between transmission axes is 90 degrees and cosine of 90 is 0. So it means that IT in this case is equal to 0. But this is not all about this question. The question is also asking us, filter B is rotated from its starting position about the line xy. So we have this line xy, as shown in figure 4.1. After rotation, the intensity of the light emerging from filter B is 1 by 4 I naught. And we need to calculate angle of rotation of filter B from its starting position. Very nice question. And so for this purpose, first of all, simply we can draw the lines. We can draw first transmission axis. So this is the filter A. So this is transmission axis of filter A. And also we can draw transmission axis of filter B. So this one is filter B. In this case, the intensity of the light after passing filter B is given to us. That is equal to I naught by 4. So now we can simply use Malus' law and we can find out the angle between these transmission axes. So we can write down IT. This one has to be equal to I naught cosine square of theta. And theta is the angle between two transmission axes. So in this case, IT is given to us. That is equal to I naught by 4. And we have incident intensity and cosine square theta. I naught we can cancel with I naught, so we can write down cosine square of theta. This is equal to 1 by 4. So cosine of theta, this will be equal to 1 by 2. And cosine of theta is equal to 1 by 2 if theta is equal to 60 degrees. So it simply means that the new angle between these transmission axes is equal to 60 degrees. So we can draw here. So this is filter B now. So B is placed like this now. So the angle between them is 60 degrees. We can draw this one. So this angle is 60 degrees. This angle is 60 degrees. But this is not our answer. We need to find out angle of rotation. So how much we have rotated this one? If you look at this direction of rotation, this is clockwise. So we have rotated this one clockwise. So I'll be using black color. So first of all, we have horizontal filter placed like this. This is transmission axis of horizontal filter. Then we rotate this one and we bring this one into this form. So how we can rotate this one? One way to rotate first of all this one by 90 degrees. So we can rotate this one by 90 degrees. So this is by 90 degrees. So we can just rotate by 90 degrees. Now if you rotate this one again by 60 degrees, so this will align with this. So in this case, the total angle of rotation we have, that angle of rotation is, first of all, this 90 plus this 60. So this is 60 because alternate angles are equal, plus 60. So what is total angle of rotation? So in this case, so we can say angle of rotation in this case is equal to 90 plus 60. 90 plus 60. So the angle of rotation is equal to minimum angle of rotation in this direction. That is equal to 150 degrees. So you can write down your final answer. Angle of rotation is 150 degrees. But you can also write down, you can rotate further this one. So we can use a different color now. We can use, let's say, orange color. So we can place our filter here first of all. We can rotate this one first of all by 90 degrees. First of all, we can rotate this by 90 degrees. Then again, we can rotate this by 90 degrees. And again, we can rotate by 90 degrees. So 3 times we have rotated by an angle of 90 degrees. And if we again rotate by angle of 60 degrees, so we can align this one with A at an angle of 60 degrees. So in this case, you can also say the total angle of rotation. You can say 90 times 3 plus 60. So this one will be equal to 270 plus 60. So you can also write down 330 degrees. So this answer is also acceptable. So if you write down 150, 330, both answers are acceptable. So this is how you need to answer this question. I hope this one is clear to you. For part C, it is given to us a microwave of intensity I naught and amplitude A naught meets another microwave of the same frequency and intensity of I naught by 4 traveling in opposite direction. Both microwaves are vertically plane, polarized and superposed where they meet. For C1, we need to explain without calculations why these two waves cannot form a stationary wave with zero amplitude at its nodes. So first thing we need to understand, when two waves they meet and they have zero amplitude at nodes, when that is possible. That is only possible, imagine that we have two waves. Let's say we have wave 1 and let's say we have another wave. We can use a different color. Let's say we have another wave. So this is another wave. And these two waves, they are traveling in opposite directions and they have the same amplitude. Let's say amplitude of this wave is A naught and amplitude of this wave is also A naught. And when these two waves they will meet, let's say they meet at this point. So we can draw the amplitude of one wave. So this is amplitude of one wave, and the other wave we can also draw. So this one is the other wave. So we can also draw over this wave. So just 1 minute. So we can draw in a proper way. So we can draw this is over other wave. So in this case, when these two waves, they will superpose, the resultant amplitude of resultant wave will be 0. Means they will cancel each other completely. So complete cancellation will take place in this case. So the resultant amplitude will be equal to 0. You can also understand A naught minus A naught. This one will be equal to 0. At any point, means if I take this displacement of this wave, I will take this displacement. One you can see negative, one is positive. If I take maximum displacement amplitude, these two also equal but in opposite direction. So resultant amplitude will be 0. And so this is possible when two waves they have the same amplitude. But in this case, the amplitude of waves is different because the intensity is different. Actually, amplitude of this wave will be equal to A naught by 2 because its intensity is 1 by 4 I naught. And intensity is equal to K times A square. So this, if this one is I naught by 4, this has to be A naught by 2. So in this case, we have one wave. You can, again, we can draw. We have one wave here. So this is one wave. And other wave we have, we can use different colors. So let's say we have this is another wave. So these are two different waves in this case. So this wave has amplitude A naught and this one has amplitude A naught by 2. So when these two waves they will meet, so let's say they meet at this point. So we have red wave, we can redraw. So this one is the red wave. So these two waves, when they will meet, they will not cancel each other 100%. So in this case, they will be resultant wave. So the resultant wave, we can use this dark color. So this one will be the resultant wave. So this is what we will see. So in this case, there is no complete cancellation. Amplitude at node cannot be equal to 0. So these points you need to understand. So if you have understanding of these points, so simply we can write down our answer. In our answer, you can mention these 2 points. Waves have different amplitudes, so cannot have resultant displacement. That is always 0. So this is how you can answer. For the second part, we need to determine in terms of A naught, the maximum amplitude of the wave formed. Means the resultant amplitude of resultant wave of two progressive waves. So how we can find out? We have wave 1. Wave 1 has intensity I naught, then amplitude of wave 1 is A naught. And the second wave has intensity that is I naught by 4. So we can find out the amplitude of the second wave. We can say amplitude of second wave is A2. And we can find out value of A2. And so in this case, we need to understand the ratio between intensity and the amplitude square. This one is constant. So we can say I naught by 4 divided by A2 square. This also will be constant. So we can simplify this one. We can say I naught by A naught square. This one will be equal to I naught divided by 4 A2 square. A2 square. So in this case, I naught we can cancel with I naught. So then we can write down 4A2 square. This one has to be equal to A naught square. We need to find out value of A2. So A2 we need to find out. So we can write down this is A naught square by 4. So this is A2 square. And from here we can write down A2. This one will be equal to A naught divided by 2. Because if we take square root on both sides, we will get A2 is equal to A naught by 2. So the A2 is half of the amplitude of wave 1. Half of amplitude of wave 1. But question is asking us to calculate the maximum amplitude. So in this case, we have two waves. So we can calculate A max. Maximum amplitude is when waves interfere constructively. So simply you need to add their amplitudes. So we have A naught plus we have a naught by 2. So this is simply equal to 3 by 2 a naught, or simply we can say this is equal to 1.5 a naught. So this is our final answer, 1.5 a naught. Quite straightforward question. So if you have basic understanding of intensity, so intensity over a square, this is equal to constant. So, and that is true for both waves. So that's the reason we can compare them. So the ratio between I naught and a naught square, and ratio between I2 and a2 square is constant. So we can equate and we can find value of a2. And when we have value of a2, simply you need to add that, and you can find the maximum amplitude of resultant wave. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions on electricity and radioactivity from October-November 2022, paper 2, variant 1. In this lesson, as always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together, let's improve together. For question number 5, part A, we need to state Ohm's law. And Ohm's law is a fundamental law in electricity, so understanding of this law is important to understand this topic. Let's try to understand this one with the help of a simple circuit. In that we have an ideal power supply, and also we have a variable resistor. So this one is variable resistor. This variable resistor is connected in series with a fixed resistor. And all these components, they are connected in series. In this case, we can also connect a voltmeter across this resistor, so we can find the potential difference across this fixed resistor. We can also imagine in this case the initial resistance of variable resistor, let's say that is RV, and initial current in the circuit, let's say is I naught. Now if we decrease the resistance of this variable resistor, so in this case I hope you will simply say I nu will increase, meaning there will be more current in the circuit, and current in the circuit will be equal to EMF of power supply divided by total resistance in the circuit. So we have RV plus R. If we decrease in this case RV, so I nu will increase. If I nu increase, it means current passing through this resistor will increase. If current passing through this resistor increase, it means the V across this resistor, meaning the potential difference across this resistor will also increase. And this is Ohm's law. Ohm's law simply tells us that V is directly proportional to I if T remains constant, if temperature of the conductor remains constant. So simply we can say if T is constant, then V is directly proportional to I. Or we can say V is equal to I times R. So R is resistance of resistor, and V is the PD across resistor. So this is across resistor, and I is current passing through resistor. Now you can say passing through conductor. So if you have understanding of these points, now we can write down our answer. In the answer, you have to mention these points. These 2 points you have to mention to get 2 points. The first point, we can say current passing through conductor is directly proportional to potential difference across conductor if temperature of conductor remains constant. So if you mention these 2 points, you will get 2 marks. For part B, it is given to us the variation of current I with potential difference V for a filament lamp is shown in figure 5.1. The resistance of filament lamp increases with potential difference. We need to state how figure 5.1 shows this. Means the resistance of filament lamp is increasing with potential difference. How we can conclude this one using this figure. So first thing, we need to understand how resistance, potential difference, and current, they are linked with each other. The resistance is equal to the ratio between V and I. So let's try to understand how the ratio is increasing. So it simply means that in this case the ratio between V and I is increasing because resistance of the resistor is increasing with potential difference. So we can take 2 different points. Let's say we take this point. So if we draw this dotted line here, so this is one we will consider. So in this case you can see the increase in V is this much. So this is the change in V. How about the change in I? Change in I is this much. So the change in I is very small as compared with change in V. So it means the ratio is increasing. We can also take the next point. If we consider the next from here to here, we can take this one, but its better way is we can draw at this point. So here. So in this case, we can draw draw here. So you can draw a little bit proper. So this is in a proper way we can draw. Now if we compare in this case, so this is over delta V. How about the increase? Increase in current is even getting smaller. So it means overall ratio between V and I is increasing. So it means the resistance is increasing. So simply we can say as the ratio between V and I increases, it means resistance increases. So this is how you can write down your answer. Now, if we go to the second part, question is asking us to explain why the resistance varies in this way. So the first thing we need to understand, if the potential difference across resistor increase, if delta V across resistor increase, it means more electrical energy has been converted into thermal energy. So we can say electrical energy, more electrical energy converted into thermal energy, or simply we can say in this case current increases. More electrical energy converted into thermal energy. So it means that if more thermal energy is produced, it means temperature of resistor will increase. And as temperature of resistor increases, its resistance also increases. So these points we need to understand. Explain why. Delta V greater across resistor means that greater electrical energy converted into thermal energy. So if greater electrical energy converted into thermal energy, it means the resistance of resistor will increase, or simply in a better way to say is more thermal energy means there is a big change in temperature. If there is a big change in temperature, it means resistance will increase more. So that's the reason when potential difference across resistor increases, resistance of resistor increases because temperature increases. So if you write down these points, you will get 1 mark. So this is how you can write down your answer. For the answer, simply we can say as PD increases, current increases, so temperature increases. If temperature increases, it means resistance of filament lamp increases. Or better way to explain is like this. As potential difference increase, it means more electrical energy is converted into thermal energy in resistor. So the temperature of the resistor will increase, so its resistance will increase. For part C, it is given to us figure 5.2 shows a circuit with a battery of electromotive force 12 volts connected to a linear potentiometer AB and two identical filament lamps P and Q. The battery has negligible internal resistance and lamps each have the same IV characteristics shown in figure 5.1. When the slider of the potentiometer is at its midpoint as shown in figure 5.2, current in the battery is 1.78A. Determine the current in lamp P. Current in lamp P. So the first thing we need to understand, as this is slider is at the midpoint. So if we connect our voltmeter across this lamp, so the reading on this voltmeter has to be equal to 6 volts. So now we have value of potential difference across the lamp. So we can find out value of current because we have IV curve for the lamp. So simply we have 6 volts. And so from 6 volts, we can simply draw this dotted line. So we can read current from this curve. So if we check value with y-axis, because y-axis, from the y-axis you can find value of current. And this value is 1.55. So current passing through lamp P has to be 1.55 amps. So this is what you need to write down. So the main thing is you need to understand how to read this IV curve. For the second part, we need to calculate the total power dissipated in lamps P and Q. And we have the value of potential difference across these two lamps. So simply if we connect our voltmeter across these two lamps, the reading on this voltmeter will be equal to 12 volts. And also we have current passing through this lamp P. But the problem is that is current is flowing this way or not. To understand that point, we can take this point. Potential at this point we have discussed is equal to 6 volts. And potential at this point is also 6 volts. It means no current will flow this way. So simply we can take current passing through lamp P, that was equal to 1.55 amps, and we have potential difference across these two lamps, so we can calculate the total power dissipated in P and Q. So we can say power dissipated in P and Q, this will be equal to V across P and Q. So we can say V across P and Q times the total current passing through these two lamps. We have value of V, that is 12 volts, and current is 1.55. So if we solve this one, our final answer will be equal to 19 watts up to 2 SF. So we have to use 2 SF. So final answer is 19 watts. For the next part, we need to calculate the resistance of potentiometer between its ends A and B. Means what is the resistance of this potentiometer between ends A and B. So first of all, we can connect our voltmeter here. If we connect voltmeter across this potentiometer, so simply we can find out the reading on this one has to be equal to the EMF of this power supply. So the reading across A and B is equal to 12 volts. And also in this question, it is given to us that I total in the battery, means in this circuit, is equal to 1.78. So current passing through this one, we can find out, means current passing through AB, let's say that current is I1, and current coming from the battery is I0, and I2 already we have calculated. So simply in this case, we have 1.78 I0. This one is equal to I1 plus I2. So we need to find out value of I1. So I1 simply will be equal to 1.78 minus 1.55. So we can find out value of I1. That is 0.23 amps. Now we have value of current passing through this potentiometer, and also we have the potential difference across this one. So simply we can calculate resistance. So resistance is simply equal to potential difference divided by current passing through this potentiometer. So we have 12 volts divided by 0.23 amps. So the final answer in this case will be equal to 52 ohms. So this is 52 ohms. We have to use 2 SF because the least number of SF in raw data, we have 2 SF. So we are using 2 SF here. So this is our final answer. For part D, it is given to us the slider of the potentiometer in C is moved to end A. State and explain the effect on the brightness of lamps P and Q. So this slider, if we move from this point to this end, so simply we can draw the lines here. So we can connect this one at point A. Now the potential at this point, because this is an ideal wire, so potential at this point will be equal to 12 volts, and potential at this point also will be equal to 12 volts. If potential here is 12 volts and this is slider, this is just a wire, so the potential at this point also has to be equal to 12 volts, and potential here is also 12 volts. So if we connect our voltmeter across this lamp P, potential difference across this lamp will be equal to 0 volt. If potential difference across this lamp P is equal to 0 volts, it means that the potential difference across lamp Q, we can also consider this point here, potential will be 0. So here we can take potential is 0. So if we connect voltmeter across lamp Q, potential difference across this lamp Q has to be equal to 12 volts. So it simply means that this one will be off, lamp P will be off, and lamp Q will be brighter than before because its potential difference increased from 6 to 12 volts. So this one is brighter, and this one go off because its potential difference decreases from 6 to 0 volts. So this one will go off and Q will be brighter. So these 2 points simply we need to write down. So this is how you can write down your answer. You can write down these 2 points. If you write down these 2 points, you will get 2 marks. For lamp P, you can see PD across lamp decreases to 0. So it will go out, it will be off, and PD across lamp Q increases to 12, means 6 to 12. So this one will be brighter. So if you write down these 2 points, you will get 2 marks. For question number 6, part A, it is given to us a lepton is an example of a fundamental particle. We need to state what is meant by fundamental particle. A particle is a fundamental particle if it has no internal structure or if it cannot be broken into smaller particles. So we call that particle is a fundamental particle. So simply for the answer of this question, you can write down these are two possible answers. You can write down particle with no internal structure, or you can say particle which cannot be broken down into anything smaller, means into smaller particles. So we call that particle is fundamental particle. For part B, it is given to us a lambda particle is a hadron that consists of an up quark, a down quark, and a strange quark. We need to show that the charge on lambda particle is 0. So in this case, the composition of particle is given to us. So simply we can write down, in this case, the composition of the particle is given. This particle has one up quark, it has one down quark, it has one strange quark. We need to find out the total charge on this particle is equal to 0. So the charge on this particle, simply we can write down, let's say the charge on this particle is Q. So we can say the charge on this particle is Q, and it is given to us Q is equal to 0. So we need to show that it is equal to 0. Charge on one up quark is plus 2 by 3e, and the charge on one down quark is minus 1 over 3e, and the charge on strange quark is also minus 1 over 3e. So if we add all together, so you will get plus 2 by 3e minus 2 by 3e. So the total charge on lambda particle is equal to 0. So if you write down these steps, you will get 2 marks. For part C, it is given to us the lambda particle is unstable. It can decay into a neutron and a pion as shown by this nuclear decay. The pion particle consists of an up quark and an up anti-quark. Compare the properties of an up quark and an up anti-quark. So quark and anti-quark. So first thing we can say they are particle and antiparticle, or we can say matter and antimatter. So we can say particle and antiparticle. So you can also say matter and antimatter. So let me write down in this case matter and antimatter. So better to say is matter and antimatter. So we can say in this case this is matter and this one is antimatter. So we can write down in this way. So matter and antimatter, and both particles they have the same mass. Matter and antimatter they have same mass. So we can say they have same mass, but they have opposite charge. Quark and anti-quark they have opposite charge. So we can say they have opposite charge. So we can also write down they have opposite sign of charge, and also magnitude of charge the same. So you can say they will have equal magnitude of charge. Equal magnitude of charge. So we can write down these points about up quark and anti-up quark because these two are particle and anti-particle, and also these two particles mean up quark and up anti-quark they are fundamental particles. You can say both of them they are fundamental particles. So they are fundamental particles. So we can also add this point, fundamental particles. So if you write on this one, you will get 2 marks. Let's go to the second part. We need to explain why the neutron is classed as a baryon and the pion particle is classed as a meson. I mean, this one neutron is classified as a baryon and pion is classified as a meson. If you look at composition of neutron consists of one up quark and it consists of 2 down quark. And if we look at pion, it consists of up quark and it consists of 1 up anti-quark. So in this case, if we look at the composition, we can simply say from here, because this one is baryon. This is baryon and this one is meson. Baryon consists of 3 quarks. So neutron consists of 3 quarks, so neutron is baryon. So it consists of 3 quarks. So neutron is baryon and meson it consists of quark and anti-quark. I mean it consists of 2 particles, quark and anti-quark. So it consists of 2 quarks, quark and anti-quark. So this one is meson because meson consists of 2 quarks. This consists of 3. So meson consists of 1 quark and 1 anti-quark. as pion consists of one quark and one antiquark. So this one is meson and this one is baryon. So this is what we need to say. If you write down these points, you will get 4 marks for part C. I hope these questions are clear to you, and we have finished this paper, and I'll be uploading the solution of whole paper very soon. See you next video.